Hey everyone, and welcome to this tutorial on Quicksort and how to implement this algorithm in Python. Quicksort is a divide and conquer algorithm. In general, a divide and conquer algorithm breaks down a complex problem into multiple subproblems, and those subproblems recursively into smaller subproblems until those subproblems become very easy to solve, and at the end those solutions are combined to solve the original problem. In a minute you will see how Quicksort implements this principle. First of all, the running time of Quicksort depends heavily on how you pick the pivot element. What the pivot element is, you will see also on the next slide. But this leads to O of n squared worst case running time and an O of n log n best and average case running time. But when a good pivot element is used, Quicksort is still very efficient and still widely used today as a sorting algorithm. So the general principle of Quicksort is to choose a pivot element. This can be any element of the array to sort, but in our case, we use always the last one. But you could use also a random element, for example. After you've chosen a pivot element, you store every element that is less than the pivot element in the left subarray, and every element that is greater than this pivot element in the right subarray. And then you have two subarrays which are smaller than the original one, and you can call Quicksort on them recursively. So you call Quicksort on the left subarray, and you call Quicksort on the right subarray. This recursion will go on until the array size is 1, and when the array size of a subarray is 1, it is already sorted, and Quicksort needs to do nothing but to return this one element. So now let me show you this example to clarify how Quicksort works. So remember that our goal is to choose a pivot element. In this case, just use the last element, the 44 as a pivot element. And now in the first iteration, we want to have 44 in the right place of this array, and all elements that are less than 44 should be stored left of this 44, and all the other elements that are greater than 44 should be stored right of the 44. Quicksort uses two indexes, I and j, that iterate through this array. And now I goes from left to right in the array, and j goes from right to left in the array. And I looks for an element that is bigger than the pivot element, and j looks for an element that is less than the pivot element. Let's start with I. I looks for an element that is bigger than 44. So 22 is not bigger than 44. 11 is not bigger than 44. But 88 is bigger than 44. So now it's j's turn to look for an element that is less than 44. J in this case just does nothing because 33 is already less than 44. And now we swap the element at index I with this element at index j. And now this procedure starts again. I looks for an element that's bigger than 44. So I looks at the 66 at next and sees that it's bigger than 44 and stops here. So j sees that 88 is bigger than 44, so it moves left. 77 is bigger than 44, it moves left. 55 is bigger than 44, it moves left. At the 66, it moves left. And now it is found the 33. Now we have the case that j is left of I. And when j is left of I, we're basically done with the sorting for the first step of Quicksort. And now we just have to swap element at index I with the element at index p. So we swap those two numbers, and what you can see is the 44 is in the right place, and every element left of 44 is less than 44, and every element right of 44 is greater than 44. And now we can just recursively call Quicksort on both of these subarrays. So let's start with the left subarray. When we call Quicksort on this, we again choose our pivot element as the 33, so the rightmost element of the subarray. At index I starts again at the leftmost element, and index j starts at the position left of index p. What we now do is the same procedure. With I, we look for an element that is bigger than the pivot element. So 22 is not bigger than 33. 11 is not bigger than 33. And when I reaches the right side of the subarray, it just stops there, and it's j's turn. J looks for an element that is less than 33, so it can just stop at the 11. And we're done with this step of quicksort. Now, remember the condition that when J is left of I, our quicksort for this subarray stops. And we switch the element at index I with the element at index P. So in this case, we would swap the 33 with the 33, so nothing happens. But we see that this 33 is already on the right place. Now we have an even smaller subarray to sort, left of the 33, the 22 and the 11. This smaller subarray will be also sorted using quicksort. We again choose the rightmost element as P, our pivot element. I points always at the first element in this array, and J points at the left element of the pivot element. Our condition when we stop our quicksort step is actually when J is less or equal to I. So in this case, we don't do anything. We don't move our indexes. We just swap the element at index I with the element at index P. So we swap those two and see that 11, our pivot element, is in its right place. Now, quicksort is called on the 22, and if quicksort is called on only one element, it will be automatically sorted. And as you can see, those recursive calls of quicksort sorted the left subarray left of the 44. If you have trouble understanding how the indexes move and when, and how the conditions are, you just have to wait a bit for the code. And then I would suggest that you go through the example once again, while you have the code open, and really get into detail with it, because it can be a little bit confusing in the beginning. But maybe when I explain how this right subarray right to the 44 is sorted, this will help you to get a deeper understanding of quicksort. So first of all, we choose 66 as our pivot element because it's the right one. We set I to the leftmost element and J to the element left of P. And with I, we look for an element that is bigger than 66. We find the 77 and stop here, and now it's J's turn. J looks for an element that is smaller than 66. So it moves to the 55. And now our condition is true that J is less or equal to I, and our quicksort step for this subarray ends with the swapping of the element at index I with the element at index P. And once again, this should make clear that we now have two smaller subarrays, one that only consists of the 55 left to the 66, and one that consists of the 88 and the 77 right to the 66. When we call quicksort on the 55, nothing happens. It just returns the 55 and says, this is already sorted. And when we call quicksort on the right subarray, we again set 77 as our pivot element. I will be the leftmost element and J will be the element left of P. And since our condition is true that J is less or equal to I, we just have to check if we need to do a swap. In this case, we do need to do a swap because 88 is greater than 77. So we just swap those two. See that our 77 is in the right place. And at last we call quicksort on the 88, which will just return 88. And now you can see the right subarray right to the 44 is sorted. And those were all recursive calls of quicksort. And this leaves us with our whole original array in a sorted order. And now we're ready to start with the implementation. Now let's look at how this algorithm is formalized in code. Let's write a function in Python called quicksort, using the def keyword and ending the line with a colon. This function will have three parameters: the array, and left and right. And left and right are indexes that determine the part of the array that we want to sort. In the beginning, we want to sort the whole array so that left will be 0 and right will be the length of the array. If the length of the subarray to sort is just 1, quicksort does nothing. So let's insert this if statement. that just checks if left is less than right, which means that the subarray contains at least 2 elements. Now we call another function, which is called partition, and this array will get the same parameters. Let us declare this partition function further below. A thing we need to know now is that this partition function returns the index of the pivot element after the first step of Quicksort. So when we have this index saved in partition pos, we can call Quicksort on the original array from index left to index partition position -1, which just means that we call Quicksort on all elements that are less than the pivot element. And we can call Quicksort on the array from partition position +1 to the right. So we call Quicksort on the subarray that contains all elements that are greater than the pivot element. Now let's continue by defining our partition function. Inside this function, we have our known indexes from the example, the I that defines the left point of the array to sort, the J that defines the point right of the pivot, and the pivot element itself, that is just the array at index right. So you probably remember from the example that I moves to the right and J moves to the left until I and J cross. And this condition that I and J cross will be checked in this while loop by checking if I is less than J. And inside this while loop, we move I to the right and J to the left. So let's start by moving I to the right. And while I is not at the end of the array, and the element at index I is less than pivot, we increase I. Analogously, we do a similar thing to J by checking if J is greater than left, and if the element at index J is greater than pivot. But now we have to decrease J because J moves to the left. When both of those while loops are finished, we just check if those two elements crossed yet, and if they didn't cross, we need to implement a swap. We swap the element at index I with the element at index J. And now we just need to consider what happens after I and J crossed. After I and J crossed, we have this case that the array at index I is greater than pivot. And in this case, we need to do another swap and swap those two elements. So remember that right is the index that points to the pivot element. So we just swap array at index I with the array at index right. And at last, we must not forget to return I, because the quicksort function we defined earlier needs this I to determine where to split the array to call quicksort recursively. Now, let's test our implementation by defining an example array and calling quicksort on this array. Remember that we have to give our quicksort function the parameters left and right. Left, as I mentioned earlier, is 0 at the beginning, and right is the length of array -1. Then, when we print our sorted array, the result will be this sorted list. So, if you still have difficulty understanding this code or the example, I would really recommend to test another example and go step by step through this algorithm and keep track of all the indexes, and then you will probably get a pretty good understanding of how Quicksort works. But if you have further questions, feel free to ask them in the comments, and I hope this helped you, and I hope I see you in the next video.